Good morning, all. Am I audible? Good morning. Am I audible?
Yes, ma'am.
Yes,
Yes,
ma'am.
Yes, ma'am.
ma'am.
Start. Uh, as lots of students were absent in last lecture, so we have a lecture from 10 to 11. So during this, I cover revision of the fourth chapter. That whatever part we have seen last two lectures. So that we will cover in today's lecture. Meanwhile, if anybody is having any doubt, you can ask me at that point. Right? So we have started our fourth chapter. So the name of the fourth chapter was medium access control. So in this chapter, we are going. Medium access control is one of. It is a sub layer of the data link layer, and the task of this medium access control is again to provide the services or data to the network layer, as it is the sub layer of the data link layer. So in medium access control chapter, so their network we are going to consider is a broadcast network. So networks can be of two types. First one is the point-to-point network, and second one is the broadcasting network. Okay. So point-to-point network is nothing but it is an exactly the communication between exactly two nodes. Okay, suppose A and B, these are the two nodes, and if the communication is happening between exactly these two nodes, then it is called as an point-to-point network. Okay, means no other node is allowed to communicate within this. Then it is a point-to-point network, and broadcasting is nothing but one node is used to send or to receive the data number of nodes or number of systems. That is nothing but the broadcasting, and at a single time this data is being transmitted to all the nodes. That is nothing but the broadcasting, as like a radio broadcasting, TV broadcasting, and all, where one information is sent to number of users at a single time. So in this chapter, math chapter, the network or the frames that are being transmitted. So for all that, we are going to consider the broadcasting network only. Means every time we need to consider that data is being transmitted on the number of nodes, not on a single chapter, single node. So in the broadcasting network, the key issue is how to determine who gets the access of a particular channel or particular link to send or to receive the data. So you can see here, number of nodes are there, and anyone has to use a communication link at a time. So to whom this link should be given or to whom the access of the channel should be given, that should be decided. And for all that issues or to handle all that issues, we are going to consider some of the protocols, and we are going to study that protocols in this particular chapter. So what are the issues? So as I told you, as like a conference call or as like a online lecture, whenever there is a physical interaction, for example we are facing a person face to face, at that time we can recognize the person's behavior or we can have a better communication. But in case of the communication where we are not able to face the person, or it is an online or any other medium, at that time it is not possible to recognize the behavior. Means we cannot say that yes, this person is going to talk, we don't know. So at that time some misunderstanding or at a time number of communication can get happen, and due to this no one will understand what is going on, right? So such issues are also arising in a network when it is a broadcast type network. So these issues are to be handled by using some of the protocols that we have to study. Then what is this channel allocation problem? So as we have said that in case of the broadcasting network, the main issue is what, who is going to get the access of a particular channel. So that is nothing but the channel allocation. But In general, this channel allocation problem is broadly divided into two types. First one is the static channel allocation and dynamic channel allocation. So what is this static and dynamic? Static in the sense fixed. And yes, generally this all broadcasting, whatever protocols we are going to see, so all that are related with the LAN and the WAN only, these two types of the network. So static channel allocation is nothing but the fixed. Means once the strategy of allocation is decided, it will be applicable for whole network and for all the communication. So that is nothing but the static channel allocation. So what is this? So generally in the traditional way for the static channel allocation, FDM and TDM were used. FDM and TDM. So FDM is nothing but the frequency division multiplexing. Okay, frequency division multiplexing. What is this frequency division multiplexing? So suppose there are n users or n nodes are there. So among these n users or n nodes, whatever bandwidth is available, that all bandwidth is equally divided or equally distributed. And within that bandwidth only, that particular node is accessed. Okay. For example, I am having four nodes. So all these four nodes, this bandwidth is equally given and 4. And each node is allowed to access or to transmit the data within its own given bandwidth. त्याला जे allocate करून दिलेले आहे bandwidth, within that only that node is allowed to send or receive the data. That is nothing but the frequency division multiplexing. Okay, so no other node can interfere in any other's bandwidth. So that is nothing but the frequency division multiplexing. In this way, the allocation or the transmission or the access of the channel is given to the different nodes. Okay, in this way, the channel allocation is done to the different users. Okay, but this FDM is okay for small network or TDM is also okay for the small network. But if we goes on the size of the network or the number of nodes are getting increased, at that time this fixed frequency division multiplexing or time division multiplexing will not work properly. For example, suppose this FDM is done for four networks or four users. Okay, whatever bandwidth is available, that is being divided within the four users, for example. But out of whatever allocation is done, for example, suppose at a time or when the communication is happening, maybe 8 users are interested in the communication. So in that case, if the users are increasing, then remaining 4 users will not get access of this bandwidth because because of the lack of bandwidth, because we have allocated this bandwidth for the 4 users only. So remaining 4 will be not accessed or will not be able to access the bandwidth. Similarly, we have allocated the 4 users bandwidth, but suppose only 2 wants to communicate. In that case also, this allocated bandwidth will go waste for rest of the 2 users. So in such cases where network can be increased or at a communication time, if the users get changed, in that case, this traditional way of allocating channel will not work. TDM as well as FDM. That's why the next channel allocation is a dynamic channel allocation. Okay, means dynamically the channel gets access of this particular use node will get access of this channel for transmission purpose. Before going for this channel allocation, we have considered or we have seen some of these terms. Okay, 5 terms, 5 6 terms are there. Now I'm expecting some definitions or your understanding for this, all these terms, because I have repeated this many times. What is mean by the static model? What is single channel assumption? So let me know what you understood by these definitions. Any definition you can say. Yes. Can anybody tell what is mean by the static model? Hmm? Yes. What is mean by the static model? Yes. Can anybody tell? Yes. Vaibhavi Patil, roll number 20. Vikas, Neha, Vaishnavi, Arbaz, Aniket. Yes. Anybody can tell. Omkar. Hmm? What is mean by the static model, static channel assumption? यातली कुठली तरी आठवत असेल एखादी तरी डेफिनेशन. Yes. Can anybody tell? Yes. Vaishnavi Sathe, Neha, Amrita, tell me. Sakshi, Abhay. बोला बोला पट पट पट. Two times we have seen these definitions. Hmm. Yes. Abhay. In single channel assumption, only single channel will be used to transfer and receive the data. Okay, single channel assumption. Okay, good one. Good one. Collision assumption means what? Static model means what? Yes, you can write in this way also if you don't want to talk. Hmm. Good. Pratik has said the definition. Yes. Any other? Yes. Pratiksha, Charulata, Shruti. Any other definition? Any one definition you can tell. Yes. Vaibhavi Patil, Pooja, Abhishek Jadhav, Vijay Nikom. Please speak up, Vikas. See, you should give the answers. So, what is this model represent given point at a time? Model represent given point at a time. What is meaning of this? Anushka, which definition you are saying? Static model. What is this? Static model represents given point at a time. I'm not getting your answer. Yeah, three. Third one is what? Collision assumption. If at a time multiple users are sending data, then it may cause a collision. Yeah, it is okay, but what is mean by the collision assumption? Pratik, collision definition you have said rightly, but what is collision assumption? What is assumed in that? Half answer is correct. Anushka, correct your answer in brief. Model represents given point at a time. Means what? I'm not getting excited. हाँ meanwhile बाकीचे नेहा गाडगे विशाल बोला बोला. Carrier sense means what? No carrier sense means what? We have seen protocols on these two also. Slotted time, continuous time. It is very easy. Yeah, speak up. प्रतिभा, शीतल वापस आहेत का? Yes, Sanika, Shivani. Don't wait for your turn. You can take. Hmm. Yes, Anushka, have you given the answer properly? Carrier says detects is line clear. If clear, then allows to send the data. Right. Good. Actually, carrier says first checks detects ऐवजी checks. Okay. You have given your own answer. Right. Good one. Only Pratik is attending my lecture. Huh? That is the conclusion. Others are just listening me, not attending. Huh? Now we'll apply one strategy. Those who will give the answer only those presently I'll consider. Hmm? Yes, Arbaz, Vishal. काय फरक पडत नाही का? Huh? Yes, Shakshi has given some answer. Right. Now I'm getting the answer. Good. Shakshi, okay. Carrier says access with the collision avoidance and no carrier says is totally opposite of carrier says. Okay. Sakshi, whatever answer you have given, that is related with the protocols which are there with the carrier cells. That protocol we have seen, they are working, you are telling, but it is okay. Hmm. So I'll tell you the exact definition. What is this? First is what static model, set of relationships that do not change with time. That is static model. Okay. Any other answers? Pratibha has given the answer. Okay. Any other? Okay, so I'll give the definitions of this. Static model means what? Static model, suppose there are n independent stations, each with the program and user that generates frame for transmission. So suppose number of users stations are there and they generates the frame for transmission purpose. And once frame has been generated, the station is blocked and does nothing until that frame has been successfully transmitted. Suppose station A is there and it has a frame to send. त्याला काय frame आहे. So unless and until this frame reaches to its proper destination, this station A is not allowed to do anything else. दुसरी फ्रेम जनरेट करायची, ती ट्रान्समिट करायची, असं बाकीचं काहीही ते करत नाही. फक्त काय करतो, फ्रेम जनरेट करतो आणि जी जनरेट झालेली फ्रेम आहे ते ट्रान्समिट करायचं काम. That is nothing but the static model. And once the frame is being transmitted, this station is blocked. Okay, so that is the definition of the static model. Yeah, so those who have given the answer, please check what you want to say. Hmm? Then next is the single channel assumption. So Pratik has given one more answer. 4-way data can be sent in given time interval. Yeah, slotted time interval we can say. Hmm? Pratik, for the slotted time. So single channel assumption is what? So as already answer is given, only one channel is available or it is used for all type of communication, for sending as well as for receiving the data. So as like we have seen in many diagrams, so only one channel is used for sending as well as for receiving the data. So that is nothing but the single channel assumption. Then next is the collision assumption. Collision means what? That Pratik has given the exact answer, that if number of frames are transmitted at the same time, then overlapping in time and the resulting signal is garbled, and it is nothing but the collision. एकाच वेळेस खूप साऱ्या फ्रेम जर सेंड केल्या तर काय होणार आहे, त्यांच्या सेम टायमिंग मुळे काय होतील, त्या फ्रेम्स एकमेकांच्या सोबत कोलाइड होते आणि ज्याच्यामुळं रिझल्टिंग सिग्नल गार्बल्ड म्हणजे चेंज होतो. and that is nothing but the collision. Okay, now collision assumption is what? In case of the MAC layer or the protocols which we are going to study in this particular chapter, so in that all protocols, it is considered that if the collision is occurred with any frame, then that frame must be retransmitted again. Okay, by using any strategy depending upon the protocol. जर एखाद्या फ्रेम सोबत कोलिजन झालं तर ती फ्रेम कंपल्सरी रिट्रान्समिट झाली पाहिजे. ओके, सो दॅट इज अज्युम्ड in the MATLAB. Okay, so that is nothing but the collision assumption. Remember this. So you might have seen in all type of the protocols we have seen this. Okay, if the any frame is collided, then again that frame is retransmitted. Then next is the continuous time. Continuous time is what? Frame transmission can begin at any instance. There is no master clock dividing time into the discrete intervals. Means once frame has started its transmission, it goes on continuous. That is nothing but the continuous time. And the example of this continuous time is aloha that we have seen. Okay, and the second one is the slotted time. Slotted time is the given time is divided into the number of slots or the intervals, we can say this, and once it is divided, each frame is allowed to send at the start of this slot only. ओके, प्रत्येक स्लॉटच्या फक्त स्टार्टिंगला ही फ्रेम सेंड करायला अलाउड असते. In the middle or at the end, nowhere else that frame will not be sent. Only at the start of this time interval, the frame is allowed to send. So station will always send the frame either at the start or it has to wait for its own turn. That is nothing but the slotted time. And the example of this slotted time is what? Slotted aloha that we have seen. So that is nothing but the slotted time. Then next is the carrier sense. It is very important, these two definitions, carrier sense and no carrier sense. Carrier is nothing but the channel जे की आपलं डेटा घेऊन जाणार आहे किंवा डेटा ट्रान्समिट करणार आहे. दॅट इज नथिंग बट द कॅरियर अँड सेन्स मीन्स चेक करायचं. Okay, carrier sense. So what is this carrier sense is nothing but before transmission of the frame or before transmitting the data, every station must check the position or the availability of the channel. If the channel is busy, then the station is not allowed to send the data unless that channel becomes idle. Right? ट्रान्समिशन करायच्या अगोदर चॅनेल चेक करायचं. जर ते चॅनेल बिझी असेल तर तो जोपर्यंत ते चॅनेल किंवा केबल किंवा मीडियम फ्री होत नाही तोपर्यंत वेट करायचा आणि वन्स इट बिकम्स फ्री देन ओनली इट अलाउड टू सेंड द डेटा. दॅट इज नथिंग बट द कॅरियर सेन्स. कॅरियर सेन्स म्हणजे लक्षात ठेवायचं की ट्रान्समिट करायच्या अगोदर चॅनेल चेक करायचं. दॅट इज नथिंग बट द कॅरियर सेन्स. अँड if it is busy, then no transmission should be done unless that channel becomes idle. That is nothing but the carrier sense. Okay, and no carrier sense means what? Channel is not checked before transmission. As the data comes, it just goes on sending. स्टेशन चेक करत नाही चॅनेल. जसा डेटा त्याच्याकडे येईल तसा तो फक्त सेंड करत राहतो. दॅट इज नथिंग बट द नो कॅरियर सेन्स. बट what is the difference in these two is that in case of the carrier sense, we can check whether your frame is collided or not in between. Okay, as we are checking the channel, we can our station is able to check the status of the channel. It is easy to define whether the collision has occurred or not. But in case of the no carrier sense, as channel is not checked at all, station is not doing anything, it just keep on sending the data. In case of the no carrier sense, it will not be able to check whether the collision is occurred or not unless that frame reaches to the destination. म्हणजे लास्ट पर्यंत कळणार नाही की फ्रेम जाते नाही जात, कोलाड झाले नाही झाले, व्हॉटएव्हर. ओके, बिकॉज चॅनेलचं स्टेटसच चेक केला जाणार नाहीये. So station will always assume that yes, I have done my work, whatever be. जातोय डेटा नाही जात. जोपर्यंत तर रिसिव्हरला मिळत नाही आणि रिसिव्हर एक्नॉलेजमेंट सेंड करत नाही की डेटा मिळालाय नाही मिळाला कोलाडेड मिळालाय वॉट एव्हर तोपर्यंत रिसेंडरला काहीही समजणार नाही. दॅट इज नथिंग बट द नो कॅरियर सेन्स प्रोटोकॉल. So these are all some of the definitions that are required or that we have used in the protocols that are used in the MAC sublet. Now anybody is having any doubt? Yes? No. Okay. So we'll see the next part. No carrier cells, no carrier cells. Now the next is the multiple access protocols. Okay, multiple access protocol. So what is this multiple access is nothing but one channel is accessed by number of users. That is nothing but the multiple access protocol. So in multiple access protocols, means all these protocols that we are going to see, we need to consider that there is only one channel and the same channel is used by number of users for sending as well as receiving the data. Okay. So first two protocols, these are very basic protocols are there, Aloha and the slotted Aloha. Okay, let's see what is this Aloha. So it is considered as a random access method. Random is anyone can access this. So random access method, and it is developed in 1970. Okay, so this name is given from the scientist and it is generated for the radio broadcasting or the wireless broadcasting mainly. So in this method, stations share the common channel. So obviously in the multiple access it is there. When the two stations transmit simultaneously, collision occur and frames are lost. So that we have seen. So this is general broadcasting strategy where only one station is used to send as well as receive the data to number of stations. So you can see here from the base station the data is being sent, okay, to the number of other station. So this is the network or the broadcasting network. Now how the Aloha is working, let's see. Suppose there are four stations are available, station 1, 2, 3 and 4. Four stations are there and they are sending their frames or their data. As there is no restriction when to send and it is a continuous timing, so the station just keep on sending the frames. ठीक आहे, स्टेशन काय करत राहणार आहे तर फक्त फ्रेम सेंड करत राहणार आहे, त्यांच्या टायमिंगला काही रेस्ट्रिक्शन नाहीये. सो प्रत्येक जण आपल्याकडे डेटा असेल त्यावेळेस तो सेंड करत राहील, राईट. नाउ what is happening due to this is that as there is no restriction on any station for when to send the data, the collision is occurring. So you can observe here is that so frame each frame is colliding with some other frame. कोणत्या ना कोणत्या फ्रेम सोबत ती कोलाइड होते. कशामुळे होते तर सपोज एका ज्या टायमिंगला स्टेशन 1 न फ्रेम सेंड केले त्याच टायमिंगला स्टेशन 3 पण सेंड करू शकतो किंवा जे ते ट्रान्समिट होतीये फ्रेम इन बिटवीन स्टेशन 3 कुठेतरी त्याच्यासोबत कोलाइड होते as there is only one medium. So it is possible. So in case of the Aloha, the chances of the collision are higher because there is no restriction on any station for timing or for sending of the data. So you can see here out of all these frames, only one frame is transmitted without any collision. So the rate of successful transmission is very low. Okay, so that is nothing but the working of Aloha. So to improve the performance or the success rate, the next is the slotted Aloha. So where the time slots are being divided into the number of intervals. So you can see here. Same strategy is there. Only what the timing is divided into the number of intervals. networks, and as it is a slotted timing, there is a restriction on every station that this station is allowed to send the data at the start of this slot only, either this, 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 or this, any. So जिथे त्याचा टाइम स्लॉट स्टार्ट होते फक्त त्याच वेळेस तो फ्रेम सेंड करू शकतो, अदरवाइज नो. If this station miss this time slot, it has to wait for a next time slot. याच्यामुळे काय होणार आहे की प्रत्येक जण जो स्लॉटेड अलोहा मध्ये कधी पण सेंड करत होता त्याच्याऐवजी काय होईल इथं रेस्ट्रिक्शन येईल प्रत्येक स्टेशन वरती, and the chances of the collision are get reduced. Okay, so this is nothing but the slotted aloha. Only difference is what, in case of the pure aloha or only aloha, the timing is a continuous and the frames are sent as it comes. Station is not having any restriction on sending of the frame, so they just keep on sending the frame as the data comes, and due to this collision is occurring or the chances of the collision are high. So to avoid this or to improve the performance, the slotted aloha is designed where the times are divided into number of slots and each station is allowed to send the frame at the start of the slot only, not in between. So every station has to wait for its own slot starting, and due to this chances of the collision are get reduced and the performance is increased. ठीक है, समझ दोन कौन से अलोहा एंड द स्लॉटेड अलोहा. इज देयर एनी डाउट? एनी डाउट? No. Any doubt? Still I'm asking. If anybody is having any doubt, please let me know. Okay. If you are not asking, I consider that you have understood everything, or you have not understood anything. I don't know. So this is the difference between these two. Now, next is the carrier sense multiple access, which is also called as the CSMA. It is given CSMA, carrier sense multiple access protocol. So there are different protocols in this that we are going to see. So it is a network access method which is used on shared network topologies, means multiple access. In this, devices are attached to the network cable, listens the carrier or the medium before transmitting. So carrier sense definition आपण बघितलेले. Carrier sense means before transmission, all stations should check whether the communication line or the medium or the carrier is busy or idle. If the channel is in use, device wait for its transmission until it becomes idle. Multiple access indicates that many devices can connect to and share the same network. Okay, so already all these things we have seen. So CSMA is developed to overcome the problem of aloha. Problem of aloha. What is this problem? Minimize the collision so as to improve the performance. So collision should get minimized in case of the carrier sense multiple access protocol. So let's see. There are certain types of the CSMA. Three types. First one is the one persistent, non-persistent, and p-persistent CSMA. What is one persistent CSMA is that when the station is ready to send a frame, it senses the channel. Obviously, as it is carrier sense, it first checks the channel. If it is busy, then again it continuously goes on sensing the channel and waits for a channel to become free. Okay. Now, once the channel becomes ideal, it sends the data or sends the frame with the probability 1, and that is the reason it is called as a one persistent CSM. And if collision is there, it waits for a random amount of time and tries again. So from diagram it will get more clear. One persistence means what? Suppose this is your carrier or channel. So in case of the one persistent CSMA, this station continuously checks the channel. तो काय करतो, continuously check करत राहतो. Busy, idle, busy, idle, busy. So as the channel is busy, again it checks, again checks to become the channel as a idle. आणि एकदा का त्याला आयडियल सापडला चॅनेल स्टेशनला की तो डेटा फ्रेम ट्रान्समिट करायला सुरुवात करतो विथ प्रोबॅबिलिटी टी 1. नाउ दिस इज कॉल्ड एज एन वन persistence CSM. Okay, it is easy. So you can see here, if the channel is busy, again it checks. If it is busy, again checks. Keep on checking, and once it becomes idle or the free, station can transmit the data. So this is one persistent CSM. Now there is some problems related with the one persistent CSMA. Is that suppose there are three stations, station A, B and C. Okay, both wants to use this channel for the communication. प्रत्येकाला हे चॅनल कम्युनिकेशन साठी यूज करेल. सो ऑब्विसली ते तिघं पण काय करणार, कंटिन्युअसली चेक करत राहणार स्टेटस. राईट. नाउ what will happen once the channel becomes free? इथे channel free झालेलं आहे. Station A, B and C, all three will sense or all three will come to know that channel is free. तिघांना पण समजणार ना चॅनल फ्री झालेला आहे. So what will happen? All three will again start the transmission at the same time, and due to this collision will occur. Correct? So as this channel is ideal for all these three stations, all three will start the sending of the data or transmission at the same time. So due to this, chances of the collision are higher. So to avoid this one problem of the one persistent CSMA, the next CSMA is a non-persistent CSMA. Okay. So what is this non-persistent CSMA? It is less greedy as compared to the one persistent CSMA. So how it works? So instead of continuous sensing, in case of the one persistent काय होतं, प्रत्येक वेळेस कंटिन्युअस सेन्स करत होता हा चॅनल इथं इथं लाईक. So in case of the non persistent CSMA, instead of continuous sensing, what this channel does, it first sense the channel station first sense the channel, and if the channel is busy, it waits for a certain amount of time. हा काय करतो, वेट करतो. Right, and again starts the sensing of the channel. If it is again busy, then again it will wait for a certain amount of time, and so on. But in case of the non-persistent CSMA, this waiting period for every channel is random or it is different. प्रत्येकाचा वेटिंग पिरियड हा काय असणार आहे, डिफरंट असणार आहे. Why different? To avoid the collision. Now, how it avoids the collision? See, suppose channel A is waiting for, or its waiting time is, for example, 3 seconds or 3 milliseconds. B's waiting time is suppose 4 milliseconds. Right? Now, हे दोघं पण काय करते, चॅनल चेक करते. ओके, मग चॅनल बिझी झाला तर चॅनल सॉरी स्टेशन ए काय करणार आहे, 3 मिलीसेकंड पुरता तो वेट करेल, पुन्हा सेन्स करेल, अगेन फॉर 3 मिलीसेकंड पुन्हा सेन्स करेल लाईक. बी काय करेल, सेन्स करेल 4 मिलीसेकंड वेट करेल, पुन्हा सेन्स करेल 4 मिलीसेकंड वेट करेल. याच्यामुळे काय होणार आहे, जो वन पर्सिस्टंट सीएसएमए मध्ये एकाच वेळेला जे दोघांना सापडत होता चॅनल आयडियल, त्याच्या ऐवजी एकालाच काय करेल, तो आयडियल सापडेल, से ए ला सापडेल. सो ए काय करेल, त्याचं ट्रान्समिशन ऍट द सेम मोमेंट स्टार्ट करेल. सो वेन द बी will come to know the channel is ideal, already A has started its transmission. A ने स्वतःचं ट्रान्समिशन ऑलरेडी स्टार्ट केलेलं असणार. So due to this, collision can be avoided. Okay, so this is nothing but the non-persistence CSM. Correct, but again there are some problems that this, you can see here, this waiting period is there in case of the non-persistent CSMA also. Okay, though channel is ideal here, as the timings are given to the channels, so they are not able to recognize this particular time of the ideal channel, so this particular channel will be ideal for some amount of time. So that is the problem related with the non-persistent CSM. And the last one is the pre-persistent CSMA. So how it works? So again, in case of the pre-persistent CSMA, it continuously sends the channel. Okay, it continuously sends the channel, and once the channel becomes free, then it sends the it transmits the data or transmits the frame with the probability q 1 minus p. This p is the probability for sensing of the channel, and q is 1 minus their particular busy channel probability. And by using this probability, it sends the it transmits the data. So that is nothing but the P persistence CSMA. So these are the three types of the CSMA. First one is the one persistent, then non-persistent, and P persistence CSMA. Any doubt in any of the CSMA? CSMA is what? Carrier sense multiple axis. Hmm? समजलं? The last part we'll see CSMA CD. So CSMA CD is nothing but the carrier sense multiple axis with the collision detection. ओके नाव आतापर्यंत जे आपले प्रोटोकॉल्स किंवा सीएसएम आपण बघितले त्याच्यामध्ये काय होतं तर वी अजून वी सेड दॅट कोलिजन इज ऑकर्ड कोलिजन होते किंवा कमी होते जास्त होते वॉट एव्हर इट इज बट what if the collision is occurring? So it is a strategy or it is one type of method with the help of which we can detect the collision, and we will come to conclusion that something should be done with that collision. ओके मीन्स कोलिजन झालंय म्हणून तसंच नाही सोडणार आपण, तर काय होणार आहे त्याला, तर कोलिजनला करेक्टली रिस्पॉन्ड करणार आहे इफ कोलिजन इज देअर. सो दॅट इज नथिंग बट द CSMA with CD. Here it is collision detection. Now, what is this procedure or algorithm? When the frame is ready, station checks whether the channel is busy or idle. If it is busy, station waits for a channel to become idle. If idle, it starts the transmission and continuous monitoring of the data. Once the channel becomes idle, what the station does, it starts the transmission and continuous monitors the data. If no collision is occurred during the transmission, it is concluded that frame is successfully transmitted. Okay. Now, if suppose collision is there, means collision is detected, then station needs to resolve it. Stationला काय करावं लागतं, resolve करायला लागतं. But how? कसं करणार? So what the station does, if any station understands that collision is occurred, then that station sends a jammer signal to all other nodes or all other stations in a network, saying that collision is occurred, stop your data transmission. ठीक आहे. एखादं कोलिजन झालं तर एखादं स्टेशन काय करतो तर सिग्नल पाठवतो बाकीच्यांना. काय कशाचं सिग्नल पाठवतोय तर कोलिजन झालेलं आहे, डेटा ट्रान्समिशन स्टॉप झालं पाहिजे. सो दॅट इज डन. Next, once the signal is sent, jamming signal is sent by any one node, all the stations will wait for some amount of time, random amount of time, and again starts the transmission. Due to this, what will happen? Collision will be avoided. ठीक है, समझ लो. डिफरन्स समजतोय. याच्या अगोदरचे CSMA चे बघितले होते, त्याच्यामध्ये काय होतं की फक्त आपण म्हणत होतो कोलिजन झालं, कोलिजन कमी झालं किंवा रिड्यूस झालं. ओके, बट कोलिजन झालंय तर मग पुढं कोलिजन कसं अवॉइड केलं जाईल? सो दिस that is nothing but the collision detection. Okay, so as I already told you that CSMA CD is used in LAN where coaxial cable and early versions of the twisted pair cables are used. So in early cables of the of the old network, we can say this collision CSMA CD that is used, but currently the cables which are used that are not means they are fully automatically they are handling the collisions. Means अशी strategy apply करायची काही गरज नाही. So the cables are automatically handling the collision. So that is nothing but the CSM. So we will stop here for today's lecture. Next lecture we'll see the next part, and hopefully in next lecture we will cover the chapter number 4. Is there any doubt?
No, ma'am.
Everyone is active while sending the attendance only. Okay, we will stop here.
We can leave, ma'am.
Yes.